and reshare.
Brilliant.
There's obviously some intelligence in Microsoft Teams that when you start recording, cuts my image camera off. That's a wise decision. Okay, 17:32 on Thursday, the 26th of June. Let's get going with Mainframers as we present Aspire to enhancing mainframe modernization. See what we did there? Aspire. Some of that will become clearer if you don't get it in wordplay. Okay. So tonight, Matt Comer will be presenting a lovely icebreaker based on Who Wants to Be a Millionaire, with some interesting acronyms, and you'll be guessing the real value for some of the common acronyms that we bandy around in the industry. Then we're very lucky to have Kenny Stine discussing the Z17 chipset and the features. Then Benoit is going to be talking about exploitation of or leveraging of the artificial intelligence capabilities that are in Watson Code Assistant. And then I always embarrass it, well, maybe I don't, but Roland Koo is probably the most important, him and his team are probably some of the most important people in the mainframe ecosystem, as they are responsible for effectively turning source code into binaries on a mainframe for every language. So he's going to be talking about leveraging the chip along with some of the other features that when your organization start adopting Z17. And then Ben Cox is going to talk about configuration simplification with CICS. Lots of people have CICS, and it's going to be a very interesting conversation or a presentation with some questions. So let's get going with what is Mainframers. So this is our thing that we talk about. We're free, we're all volunteers. We love doing this because it's our passion. The video behind the green there is from pre-COVID when we used to meet for real. But we've continued going. That artwork there is by the genius that is Sam Catlin on the call. Here are some of the beautiful mugshots from people past and present that get involved in Mainframers. And we have the usual sort of social media presence. You're welcome to connect with us on any of the platforms that you use. Some organizations are more focused on other things, but LinkedIn, we've definitely got a presence. And please feel free to contribute. We did have a conversation with the IBM Champion organization, and they presented one of our previous events. So speaking at a Mainframers event is an advocacy event that you can put down to be counted towards your IBM Champion badge for 2025. And it's not a great ordeal to be involved. We meet every other Thursday around this time, and we share the workload so that there's no heavy lifting for any one individual. We reach out to our network to get the fantastic speakers that we get, and it's not onerous. And we love having new contributors to the organizational committee. So I popped into Kenny Stine, do more at the call with IBM's new Z17, but I'm guessing, Matt, that's the slide where you take control.
Sure.
And you are a millionaire maker.
So we like to have an icebreaker. We've done icebreakers in a few of the previous events, and they've gone down well. So we've got a quick Who Wants to Be a Millionaire quiz, interactive quiz that we would love you to join in if you're willing and able. Let me can people see the screen? Stuart, can you see the screen okay? Who Wants to Be a Millionaire?
I can.
Right.
And I'm just getting my phone ready to go to menti.com.
Brilliant.
put in that code.
So what you need to do to play, I think it's 5 questions. So Stuart is the brains behind this. I've just put it into Menti. It's just going to be a few minutes of quick fun. We've got 5 acronyms. If you can go to menti.com, what you'll need is a second device to what you're looking at the moment. So if you're on a laptop, if you've got a phone to hand or a tablet to hand, go and join on that, because you'll need to see the screen for the questions. And then on your device, you see the questions, but they're quite small font and they're all multiple choice, A, B, C, D, and it's on your device that you would select. It's just for fun. We don't have prizes, but it is a competition. It's speed. The quicker you answer, the more points you get. So there'll be people here who will know the acronyms, and good luck to you. There might be people here who don't know the acronyms, and that's absolutely fine. It's just a warm-up. So some of these acronyms could well come up in the presentations later. So it's just a bit of a warm-up for what we've got to come. So I am going to keep going. So the instructions I've said there. If you can go to menti.com 36469819, I think I've got one more slide. So you've probably got about another 30 seconds and then we'll start. So you may be the theme of this is going to be Who Wants to Be a Millionaire. I think that has traveled the world. So you may be familiar with it, but it's just a multi-choice set of questions. Right, I'm going to move on. At some stage, I will get to see who has joined. Let me just pause there. Is there anyone who is wanting to play that hasn't been able to join yet? Otherwise, just for time, I will get moving. And if you are late joining, that's also fine. You can join at any point. So if we get into question 1, question 2, you've still got a chance to join. So right, I think we are going to make a start. Oh, here we go. I can now see who has joined. Brilliant, 22 players. That's fantastic. So question 1. What does COBOL stand for? So on your device, you should have 4 options: an A, B, C, or D. Complex business oriented language, common business oriented language, common business object language, or something I can't see, common compute business outcomes, literally. Well done to the 13 of you that guessed option B. It is common business oriented language. Well done. So we have a leaderboard, and we've got at the top of the leaderboard, well done to Stephen. I'm going to keep going quite quickly here just so we can move on to the main event soon. So question 2. In DB2, what does the term DBRM stand for? A, database request module, B, DB2 resource member, C, data bind required member, or D, data builds runtime manifest. Just a few seconds left. Wow, this one was a harder one. And well done to the 9 of you that guessed database request module. And interestingly, a lot went for B. Well done.
Anybody that challenges that, Matt, it's actually called the second option, not on the mainframe. So that's why A was correct and B was not.
That makes sense. Thank you, Stuart. So we've got a new leader. Well done to Praveen. Question 3. 22 players, 23 players. Let's go. In mainframe networking, what does the term VTAM stand for? A, virtual terminal allocation mechanism, B, virtual terminal availability map, virtual TCP/IP allocation method, or D, virtual telecommunications access method? Well done to the 13 of you that could scroll down to option D. Let's see how that affects the scores. Peter Hicks was quickest on that one, and Praveen is still in the lead. Question 4. We're down to 20 players. Oh, we're nearly there. In mainframe storage, what does the acronym DFDSS stand for? Dump function delete storage services, data facility dataset services, data function defined subset storage, or disk files dump storage securely? 13 of you guessed correctly there. Well done to the 13 of you that guessed B. Looking at the scores, we may have a new leader. How is that going to affect? Peelings. Well done to Peelings. Right, final question. Oh, 19 players. In ZOS, what does the acronym APF stand for? This is a good one. Authorized Program Facility, Applied Profile Function, Availability Program Finder, or D, Advanced Programming Feature? Just a couple of seconds remaining. And 16 of you, well done to you who guessed Authorized Program Facility. Wow, so this is the final leaderboard. Well done to Peelings, 4,248 points. Congratulations. I wish we had a prize to give you. Unfortunately, we don't, but well done for knowing your mainframe acronyms. Right. I hope that was a bit of fun. I'm going to stop sharing there. And Stuart, do you want to introduce Kenny or straight to Kenny?
Sure. And if anyone's got an idea for a icebreaker quiz at another event, we'd appreciate that for input. So now I'm going to hand over to Kenny Stine. Do more at the core with IBM's new Z or Z17.
Yes, perfect. Hopefully y'all can see and hear me.
We can.
Awesome. Well, thank you all for having me here today to talk about the IBM Z17. It's truly an exciting time to be in the Z world as we are rolling out our newest, what we used to call enterprise class, but now referred to as the multi-frame IBM Z or IBM Z processor. So we're going to talk a little bit about all the different components. We're going to kind of like talk through some of the really interesting stuff we're doing around Spyre and the new stuff with the platform. So I mean, just as an overall look at what we're changing here with the IBM Z17, we're moving with our partnership with Samsung to 5nm technology. So moving from the Tellum chip, which we introduced with the Z16, to the Tellum II chip, which is a really big jump in technology for us. You know, we're going to look at a picture of the chip here in just a minute. But I mean, it's a vast increase, you know, moving 7.5 billion additional transistors packed into the same footprint that we had in the IBM Z16. Still an 8-core design. We have a new acceleration engine that's based solely around our I/O technology and innovating in our I/O framework. This is where we're bringing in some of these new Spyre adapters that are going to help with AI on our platform and really open up the aperture of what we can do from an input, output, and peripheral perspective. So again, we're still in 4 frames or 1 to 4 frames and a 19-inch rack. Kind of pulling apart some of that technology here, we're going to take a look directly at what a CPC drawer looks at. Now, I'm a very technical person and I love all the little nuts and bolts that come with IBM Z, but I understand not everyone is, you know, as deep inside the technology. So just to kind of give you an idea of what you're looking at here, this is where all the magic happens with IBMZ. Any kind of application or software that you run is running across this CPC drawer. From the very top of the picture, those little rectangles you see at the very top are the interconnects that connect all the other drawers that could potentially exist in the system. So our Z17 can have up to 4 drawers, 4 of these compute drawers that can work together. These drawers are connected through those interfaces that connect directly into the center of the picture, which you can see the cooling plates that go over our dual chip modules. So one of the fun reasons is I don't live in Poughkeepsie, but I do like to go there quite often, where all the development happens. But now I have a minder because I keep stealing things. So if you ever find me in the real world, or especially in the US, I will have most of these things on me. I don't think I can travel abroad with them because of export restrictions. But this is a Tellum II dual chip module, and this is the bare die that actually is part of that Tellum II chip. It's very small when you think about the amount of technology that's packed into this. This chip right here has the ability to access up to 2 PCIe Gen 5 interfaces, which that means they run at 64 gigabytes per second for our I/O interface to go out to our peripheral devices. It has up to 1 memory controller per Tellum II chip, which means you could connect to up to 16 independent DIMMs with 1 dual chip module. We have the ability to have an integrated accelerator for AI in each of these Tellum II chips, as well as an integrated accelerator for Z Enterprise Data Compression, which is just accelerating compression in ZOS, as well as Linux. And then on these chips as well is a data processing unit, which is where we're finding all of this new innovation in the I/O section, in our ability to bring in new I/O cards and really see some cool consolidation of I/O adapters on IBMZ. Looking at the memory, just kind of moving right back down, this is similar memory to what we had on our Z16. We can have up to 48 DIMMs in a drawer, and what that translates to you as a client is up to 64 terabytes of main memory in a fully loaded system, up to 16 terabytes in a single CPC drawer, which is a vast increase over what we've offered in the past. Kind of going in just a little further, looking at this bare die and what it's capable of. This 8-core chip has 31 billion transistors that are dedicated to the computational power that IBMZ brings. That's 7.5 billion more transistors than what was available on a Tellum chip that was in a Z16. And again, this little tiny chip, 23 millimeters by 22 millimeters, is 24.1 miles of copper wiring when you string it all out. As you can see in our little block diagram here, we have our different accelerators. At the top is our compression accelerator. The very bottom is the AI accelerator, which is really driving that new workload that we're looking at on the system. And in the very center here, we have our data processing unit, which is going to be where we're bringing in these new I/O adapters, where we're bringing in new capabilities to Z, and also allowing us to innovate every generation with new DPUs to further bring new technology to our platform. So this is really opening the aperture of what we can do with IBMZ. Now, there's a lot of text on this slide, and like I said, I'm a nuts and bolts kind of person. So you can look through this later and kind of catch all the little fun items that we can do. With this system, we also have virtual caching where we only implement physical L2 caching. Everything else is implemented on top of that layer. We virtualize everything so that you can use every single transistor, every bit, every item that is inside that drawer to really power through what you want to do. Looking at that AI framework, a big focus in the Z17 is what we can do with AI, both on the core itself and from an overall ecosystem perspective. With the Z16, we first brought in the ability to have an AI inferencing accelerator on the core itself and really drive some of those analytic workloads. With the Z17, we're perfecting that approach, really driving hard into the ecosystem that's out there to deploy AI-based workloads or inferencing workloads on IBMZ. As you can see, we have a large increase in our AI capability, looking at our benchmarking study here of going up to 450 billion inferencing operations with a 1 millisecond response time. That's a 150 billion increase over what the Z16 was capable of at full tilt. We have a larger AI throughput because we are parallelizing our access to our AI accelerators across the entire compute drawer. As I said, we're really virtualizing every aspect of the hardware that's located in Z so that you can utilize every single bit possible to get that workload done. And on top of that, through our studies, we are shown to use 83% less power when compared to those AI workloads running on x86 servers over a span of 2 years. So really a powerhouse for AI. And what we want to see is driving the adoption of AI through the IBM Spyre adapter, which will become available later this year. In fourth quarter, you'll be able to get the Spyre adapter. Right now, you can reserve the Spyre adapter, so there's space for it on your IBM Z if you want to order it before they're available. But what we're really looking to see is driving this adoption of AI technology and giving you a platform that can really chew through what AI can do for you. We're looking to see not just what you could do from an inferencing perspective, like being able to look at structured data and pull information from it and look for fraud and look for these scoring algorithms, which we've had in the past. But we want to go a step further and really integrate AI into every aspect of what you do on Z, looking at the implementations of assistants and agents. It's really wonderful, the art of the possible that we can do with the Z17 and the IBM Spyre adapters. If you have implemented something like the Watsonx assistant for Z, you could have a chat-like interface that has hook-ins and agents and assistants, essentially, that have hook-ins and automation to where you could say, talking to your AI platform, I want to IPL my production LPAR, let's call it LPAR 1, and it has the ability to go through and figure out all the things it needs to do to create the load parameters, to drive that load process, and then respond to you with everything is complete. Or, hey, I have an issue with CICS or an issue with DB2. I'd like to know more about it. And it can integrate with services like, or with agents that exist like in ServiceNow, and pull together different agents that have certain tasks to build a holistic view of the problem you're facing and give you recommendations of steps that you can take. And then you could just say, go do that. And that automation can drive that. Now, of course, this is far looking of what the art of the possible is with AI and these assistants and agents, but it's really where a lot of the development and a lot of drive for Z is going. That's why we have a huge focus on the AI accelerators that run on these dual chip modules, because you can run a lot of this within the technology we provide on the system. And then to expand it even further, when we look at large language models in, let's say, the millions, we can run directly here. But when we look at large language models in the billions of tokens, where we're really doing language processing and highly intensive computational transactions, we have the Spyre adapter, which comes directly from IBM Research. It's a huge step forward for what we can do from an AI perspective, where you can kind of see it in the upper corner of this screen here. It's 32 accelerators all packed into a tight interface in a PCI card that pulls no more than 75 watts. And we can put many of these together. We sell them in sets of 8 so they can cluster together to give you the availability that you expect from IBM Z and really drive those generative AI workloads. Especially, again, the beginning focus is going to be that Watsonx assistant for Z and the Watsonx code assistant for Z. So there's a lot of wonderful things that we can do on the platform around AI, driving that work directly on the core. And when we get to that more complex computative process, we have those Spyre adapters that are right there in the IO drawers that we can then offload those transactions to and really drive work on Z. Just looking at the highlights, from a Z16, we're looking at 11% increase in overall performance. Now, performance can kind of be a bit of a misnomer. We're not saying it's a direct 11% increase in how much you can process across it, but overall, from its nest architecture to its computational ability to its transaction volume, we're looking at 11% through the benchmark studies that we do. Moving from a max 200 to the max 208, we have a capacity growth overall possible on the system of about 20% when we look at the total capacity and throughput that the Z17 is capable of. We moved from 40 terabytes of memory to a total of 64 terabytes of memory. And even if you're not ordering the most memory you can possibly order on the box, this opens up the ability for you to have more memory in the space you already have, moving from a 16 to a 17 or 15 to a 17. Really giving you the ability to put more things in memory and drive more workload across those processors. And all of that we're doing is using 19% less power on an average system overall than a Z16. Improvements like that data processing unit has allowed us to remove a lot of the ASICs that we would have inside of our I/O adapters, which has had a really nice impact overall on the power footprint of the platform. So it's truly an amazing platform. And if you get a chance and you can go out on the internet, there is the Kaon tool. This is also an app you can get on your phone. But it's a 3D interactive map of what the Z17 looks like. And in fact, with this generation, they've actually made it so that we have the ability to do guided tours. So you can click through this app and it'll take pieces out, show you all the components. It's a fascinating way to get to see a Z17, even if you can't go into your own data center. But I did want to show you what a fully loaded Z17 would look like. So this would be our Max 208 model with 4 CPC drawers, 208 customer cores, with additional cores on top for our data processing and things like that, up to 12 I/O drawers, which can have some of our new FICON and Networking Express cards. What's really interesting about this generation is port consolidation. A lot of clients are going to see the ability to shrink the number of I/O drawers they have or the number of frames they need, because we're moving from 2-port FICON to 4-port FICON. We're moving from 1-port OSA cards to 2-port Networking Express. All of this is going to drive the ability to do more with less and really, really see what the powerhouse that the IBM Z can deliver. On top of that, we have the introduction of those Spyre adapters, which will go right here in the I/O drawer, which directly interact with the CPC drawer. Most of your processing is still going to be done on those dual chip modules. But when you get to those large, complex computational items, we can offload that to a specialized AI card that can go through that computation and bring it back. Really a nice synergy between what is capable, what our processors are capable of, and what the system overall can drive. So I know I only had about 15 minutes to kind of go through this, and I want to leave you with the high. Oh, I'm on the wrong screen. That's fine. Oops, wrong button. My apologies. I want to kind of leave you with, the overall design of the system, and what we as IBM really want to see is that fueling growth in AI, but also just transforming what we can do on this system through the use of artificial intelligence. Streamlining our IT operations. If you look at some of the announcements of what we're doing with z/OS 3.2 and bringing AI into our subsystems, into DB2, into WLM, into the base operation of z/OS itself, so that it can use some of these models to make decisions to make your life easier and to make your systems run more efficiently. And on top of that, we're always looking at what security threats are out there and how we can help ensure our platform is one of the most secure on the market. Things we're bringing out to answer regulatory requirements are like z/OS malware detection, additions to quantum safe algorithms being implemented on the system in all the places that we can possibly implement it. And as well as just simplifying the ability to answer to some of these regulatory bodies through different frameworks and through different software offerings that we have here at IBM that can help integrate with the system, pull data, and get some of that information to help you pull together what you need to respond to regulators. So there's a lot that we're doing with the IBM Z17, and as the VP kind of coined the phrase of do more at the core, really that focus is what we're doing with the 17. So I think with that, my time is up, so I'll cede it back to the event. Thank you so much for giving me some time to talk about the Z17.
Thank you, Kenny. Really informative. There was one clarification from
Sure.
Dr. Cam say about, could you repeat the stat on AI power consumption?
So AI power consumption, an individual Spyre adapter has a maximum output of about 75 watts. That's mostly a maximum of the PCIe I/O adapter itself. We have 8, we sell, or we will be selling, the IBM Spyre adapters in sets of 8. So they'll kind of be bound together to kind of interoperate. And some of the benchmarking studies that they have done, I can get this is a specific proof point. So essentially what we did is we did a benchmark of using Spyre or modeling Spyre on the Z17, as well as an equivalent workload that would use a third-party kind of GPU-based solution on x86. And overall, what the benchmark came out with was an 83% less power consumption to drive that workload over a 2-year period, comparing what the x86 environment would need from a server, compute, GPU perspective to what Z can provide using that same kind of workload. The specific benchmark information would be in the little addendum, which I can provide if someone needs.
Fantastic. So I hope that answers your question, Cam. Do you know what? It's just me, but maybe this mainframe has got a future. Who knows? And also now you've talked about the Spyre Accelerator. That's where the play on words came from for the overall event, Aspire to Enhancing Mainframe Modernization. One thing you did talk about was something called Watson Code Assistant. And if only we had a bit more information about Watson Code Assistant. Is there anyone on the call that would like to share anything?
Thanks for the introduction. Yeah, let's talk about Code Assistant for Z. I'm there. So yeah, can you see my screen?
Come through now, yes.
Yes, so let's talk about AI-assisted mainframe modernization with AI. Yeah, so this is a good transition. We're going to talk about a little bit of, Spyre accelerators, and but basically what I would like to introduce in 13 minutes is, it's challenging, is how to use Code Assistant for Z to explain your code and use the agentic AI and yeah, modernize with the maximum productivity. So I'm Benoit Marolleau. I'm part of the client engineering team for Europe, Middle East, and Africa, based in Montpellier, in France. And over the past 1 year and a half, well, I've been working on more than 30 projects around application modernization with Code Assistant for Z. So I'm going to give you, my real feedback about what you can do and what you can't with the tool as of today. What's coming with Z17 and this AI stack that you can use with this new mainframe. And of course, it's gonna be more interactive. It's the only slide I have, and then I'm going to proceed with a demonstration. So of course, please, if you have any questions, we will keep time at the end for questions and answers. So please don't hesitate. All right. So this is my only slide, I promise. I have also maybe the roadmap, but I'm gonna switch quickly to Watsonx Code Assistant. So this is the landing page. So Code Assistant for Z is the big brother of Code Assistant. And so Code Assistant for Z is a technology based on generative AI that will help you modernize and gain in productivity for all your developers. This is more the generic for all the languages solution that we have. And we are here to talk about Watsonx Code Assistant for Z. So this is about mainframe modernization, or not only COBOL. It can be JCL, PL1, assembler on Z. And I'm going to talk about this. Just to mention this landing page, you will find many, all the functionalities, main functionalities that we will cover today. Today, I'm going to talk about understand and explain, refactor and optimize. which are, from my point of view, really key when you talk about application modernization, real application modernization on mainframe. And of course, you have also other features like transform and validate. And I will share with you the presentation, of course, so you can refer to it if you want to know more about this. And just to mention the fact that we just announced the Code Assistant for the 2.6 yesterday, and it's going to be available. The availability date is tomorrow, and I'm going to cover a subset of the new functionalities today. I'm going to use a beta version of the 2.6, but with the major functionalities. But referring to the 2.6, I mean, it's coming with new features for assembler modernization, using more agentic. We'll see that in the demo. And this is the landing page, and this is basically, referred in this main web page. You type Code Assistant for Z on your favorite search engine, and you're gonna find it, of course. Let's move quickly to the demo. So I have, I think, yes, maybe 8 minutes, something like that. So this is my IDE. I'm in the shoes of a developer or an architect willing to modernize my application. You can't modernize if you don't understand your application. And what we propose with Code Assistant for Z is a way to accelerate this understanding with interactive explanations coming from the generative AI. So I'm going to show you that in the next seconds. Just to give you, we say also science without conscience is the ruin of the soul. Well, this is from this is quoting a French writer from the 16th, and generative AI without context is also the ruin of soul. So and this is basically what we want to show with Code Assistant for Z. Gen AI is everywhere. When it comes to modernization, you need many information and context coming from the target environment, in that case, the mainframe. And this is what we propose with this such solution. So you see, this is the scanner, ADDI on steroids, coming with additional AI explanations. And this is basically the scanner that is going to give all the metadata and the context to the generative AI. If I go back, so I'm in the shoes of the COBOL developer, I'm going to go back then to my IDE. What I can do first is to log into the tool, so to the refactoring assistant. And this is a COBOL program. I have a COBOL application with hundreds of artifacts, as you may see. Some of them are tables, copybooks, programs. And basically what I want to do is, I know that I want to refactor a subset of my application, basically the credit debit part of the application, managing the account. And this is basically what I'm going to do. I'm going to browse my application. The good news is I can also use, based on this is one of the new functionality, which is the dynamic recording functionality that coming from Test Accelerator for Z. So what I can do is I can extract this recording and say, so this is basically data coming from the runtime, the real execution of my application, of my COBOL batch program, for instance. And I can say, apply the recording. And if I do that, I can help my developer in the refactoring work, because if I do that, and if I go back to my refactoring assistant, I just need to refresh the screen, and ATM, here we go. And once I did that, my developers can then see what's actually is being executed, and all the credit debit programs that are involved in this batch, for instance, are tagged and displayed. And this is my scenario. So what I can do from that is I can use generative AI to explain the program. As I said, you can't modernize, you can't optimize if you don't understand. And behind the scenes, it's going to use the generative AI that can stand in the cloud for customers that wants to have a hybrid deployment, but it can also be deployed on premises, on Spyre cards, for instance. So this is in the roadmap, by the way. So you can imagine to have all this generative AI standing on your favorite IBM Z with Spyre accelerators. There are many alternatives. And you see, it explained me in a few sentences. I asked for a basic summary of the application. it displays me the different paragraphs and sections and a summary of what it does. And this is the starting point. Let's say that I want then to start the refactoring. And so I push the identify paragraph, and in that case, yes. So hopefully, well, this is maybe the demo effect. Let's see if, yeah, here we go. So this is, I have a list of section, and the tool, this is refactoring assistant extension installed on VS Code, is going to help me refactor. So you see, this is the get debit credit. What I can do from that, I can say, of course, I can explain it. This is something I can ask a detailed explanation, for instance. If I do that, automatically, it's gonna interact with the generative AI. I can also ask the tool to help me isolate this portion of code for refactoring and optimization. So this is what I'm going to do right now. What I can do is, if I go back to this paragraph, I can say slice to an existing or new service. I already prepared a service once I have this, and this is basically the slices of my new refactoring here. So it explained me the COBOL code on one side that I can then add as a comment. And I have also this set of slices. So basically, it extracted me the credit debit portion of the code that I was interested in to refactor and optimize. And also it extracted, I mean, it's an assistant, so it detected that there were some dependencies in terms of copybooks and other sections of the code, other paragraphs. So it proposes me a list of things that I may want to isolate in a single business function that I may want to optimize and refactor. So this is the starting point. And then when I go there, so I have an explanation, I know what I'm doing. I can say, code assistant for Z, please generate me a service code. So in that case, so I can say, of course, I can name this COBOL, and at the end, it's going to produce me a COBOL with all the dependencies, the working storage, etc. So everything behind the scenes is covered by a rule engine and AI stuff. And then once I have this, what I can do, I can interact with my COBOL. So what I can do is I can say, okay, for instance, I can say /explain a COBOL code like, I don't know, well, the initial COBOL was ATMC F0, which was the main COBOL program in my COBOL in my batch chain. But I can also say, yeah, I can do that. I can say, explain me this program as I did previously. So I can really discuss with my code and interact with my whole application with all the dependencies. And behind the scenes, you see the trace. This is generative AI being executed next to my mainframe, on the mainframe with Spyre very soon, or in the cloud, up to you. What I can do is I can also discuss and say, I don't know this code, maybe does at ATMCF00, the code that I'm refactoring, and accounts. And this is the understanding of, then behind the scenes, it's going to be the understanding of the code and the application itself. And it's going to, of course, use the metadata. So this is more an agentic behind the scenes, agentic AI. The data coming from the scanner and the data coming from well, all the dependencies I provided to him in my workspace. So it takes a few seconds, and normally it should confirm me or not if the code is managing accounts, because as I said, my mission was to refactor the account management portion of the code, right? So this is basically what the code is doing behind the scenes. I can also, what I can do, well, let's wait for the answer. Yeah, maybe this is, I can also, based on the COBOL I just produced, I can also say, use this assistant to streamline program structure. So in that case, it's gonna maybe remove and clean up the code, remove the go-to statements, remove bad things in the code. Again, it's doing behind the scenes all the the rule engines and AI provided with the tool to streamline the COBOL, ready to be then optimized by the next component, which is called Watsonx Code Assistant Optimize. So you see, I have a proposal and I can discard or accept in terms of modification in my code, the before and after image on the left. It's going to go remove all the go-to statements, doing very clever things, and remove maybe some useless portion of the code. So really, this is a way to quickly optimize as well. And the last portion I wanted to highlight is the result of the optimizer, so the code optimizer advisor. And this is basically also included in the tool. Once you understood and refactored, you can use the tool. So there is a host component installed on the mainframe, taking benefits of the latest functionality of the C16 and Z17 now, and will give you all the advice I want to reduce this, for instance, optimize the performance, reduce the time spent in portion of the code. And this is the two reports I would like to report to display. You see the before and after. So, and I think I presented a subset of the whole chain, understand, refactored, a bit of optimized with scope explanation. And the last function that was announced yesterday is the code generation. Now I can generate code. So COBOL to get started, and it's going to be JCL. It's going to be other languages on the mainframe, taking benefits of all the AI capabilities of the new mainframe. So on that, I think it's time for me. So over to you, Matt, and thank you very much. And if you have any questions, please. Thank you very much.
Wow. You can breathe now, Benoit. Thank you. That was fantastic. I'm so glad that was recorded, because I think you went through some stuff. In the interest of non-bias against or for IBM, we know other vendors do have solutions that are based on AI. So we're just saying that, you know, there might be other options out there. This isn't a sales pitch for IBM. It's about leveraging the AI capabilities. And Benoit, great job, really exciting.
Thank you very much.
Got me interested in looking at what the Watson Code Assistant for Z can do. And for anybody that's in the UK, there is the GS UK event in November that I think IBM are going to be doing some more presentations about. So
thank you very much. Thank you. And from a practical feedbacks, as I said, I participate to more than 30 projects. So the developers really love this interactive explanation, the human in the loop, to modernize and understand better the code, not based on comments, but on real code. And of course, you can take in consideration the comments if necessary. But it's also a way to have an up-to-date documentation. And yeah, you can't modernize if you can't understand. So yeah, but thank you very much.
Thank you, Benoit. Fantastic. So you created some code using Watson Code Assistant, but doesn't run interpreted. It runs as a binary. And there's only one team on the planet that we go to turn source code into binary. And that team is led by Roland Koo. So possibly the most important team in the world, as I mentioned earlier, about getting binaries into production, turning source code, COBOL, BL1, and a bit of the advanced binary optimization. Take it away, Roland.
Thank you, Stuart. My name is Roland Koo. I lead the product management team for compiler and languages, and also enterprise products on ZOS. So today I'm just going to give you an overview of what our COBOL portfolio has, the capabilities of this portfolio to help customers modernize their applications. The reason is because we have a lot of the business critical applications are still running on COBOL, and COBOL is an old language, but if you look inside the hood, it's really every bit as modern as anything. So I'm just going to go through that with you today. So the whole purpose of us advancing the technology is to help customers accelerate their application modernization, right? So there are two parts to it. You have to build the right foundation, and you need to make sure that you increase your business agility. And in terms of business agility, of course, you have to make sure that you adopt the DevOps and you have a very efficient pipeline, and use AI-driven tools like what Benoit was talking about, WCA4Z and other things, and so that you can actually keep up with that. But building the right foundation is probably more fundamental, because make sure that what it means is, like, you have to make sure that you optimize existing applications to make sure to ensure that it's running optimally on the platform, and you're getting the maximum performance out of the hardware. And then you talk about extending and enhancing the applications. A lot of people think that COBOL is very difficult to learn, but in fact, COBOL is the easiest language to learn. The difficult part is really the business logic, right? So even if you're thinking about rewriting some of the business logic in another language, you still have to deal with the business logic itself. So that's really why we just want to make sure that you have good tools to be able to help you understand your application, so that you can do the right things to modernize it, whether you refactor it or you rewrite part of it, or you translate part of it to Java or another language. That's all it's all the options options available to you now. So today I'm basically obviously going to be talking about optimize and enhance and extend applications. So there's a lot of languages that we have on the Z17 today, right? Obviously we have COBOL, and there's a sister product called Automatic Binary Optimizer, which is really optimized already compiled code without recompilation. We have PL1. PL1 is every bit as important as other languages on the platform. And assembler is also very important. And I don't know why I came to my group, and now I also is responsible to assembler as well. Obviously we have CNC++. CNC++ is part of the operating system, so it's the life cycle actually goes with ZOS rather than delivery goes with the ZOS rather than the hardware itself. And then we have Java. Java obviously is basically it's called assembler runtime, where our every bit as current on the platform as the open source community. Right now we just delivered Java 21, and then we have all the open source languages as well. So those are the language on the right, because they're really mostly influenced by open source. So staying current with that is very important, because we don't want it to enable a language onto the on the ZOS and then let it stale and get out of date, right? So now you can see that you have a lot of opportunities or a lot of options for your application modernization, because now you're not really totally bound, right, to the language that your application is very written in, because you can now pick and choose the language that would best fit your job. Is really a best fit model. And then our job here in IBM is try to make them interoperate with each other, right? So that's really what we're focusing on in the team. So back to COBOL. Really, the COBOL story is probably one of the best stories. But we don't really tell it enough, because there's no platform out there that has the collaboration between the hardware and the compiler team, right? Because in the past 20 years or so, increasing performance is quite easy, because we just need to increase the clock speed and everything runs faster, right? But that roadmap has ended, so we have to find other ways to improve the performance of this workload. So what we chose to do is that close collaboration gave us was that we look at a certain piece of the COBOL workload, because it's such an important workload on the Z platform, that we actually co-design some of the hardware features and also and new instructions, so that we just make sure that we have the instructions being supported with the compiler. So you can actually see that 6 generations of hardware, right? You can actually see what facilities we actually put in and what we're trying to target, right, in terms of application and what version of COBOL and ABL it's supported, right? I just wanted to talk a little bit about 6.5, because this is the compiler that we delivered in conjunction with the Z17. There is a new facility there. It's called Vector Enhancement Facility 3. And what it tried to improve the performance is really binary arithmetic. Because what we found out is that binary arithmetic is a very common data type. Sorry, binary is really a common data type for other languages as well. So improving this performance will be able to help the interlanguage interoperability. So that's what we have chose to do. Though we basically have new instructions, to improve the performance of binary COM5 or COM5 for data set with data items when TrumpBin is on, right? And we also heard from customers that, when they upgrade the, to version 6 from version 4, they always run into something called the invalid data problem that is very prevalent, which surprised us, by the way, a little bit, because we did not anticipate, people will be coding this way, right? But reality is they did. So what we did was then we actually put together an option, right? Instead of generating an ABAN for those invalid data, we actually would, we'll keep it going. But because the data can come in from anywhere, right? It could be from a database, it could be passing from another, another program or something like that. So sometimes customers are not confident of turning numcheck off, because that is an option that will generate extra instructions, make it very, very expensive to run. So if you do that, if you use that in production, with version 6.4, that means that your application will run a lot slower, and it will consume a lot more CPU. So what we did with version 6.5 is that we actually generate instructions to help improve the performance, right? To lower the overhead, in case if you need safety, right? But the recommendation is still, turn it off. But it really, if you absolutely must leave it on, then this is, it will give you a lot, very significant cost savings in terms of, instructions there. So on the right, you actually can see, the performance. If you run a 4.2 application based on our benchmark, you actually can see that, there is a lot of performance you're leaving on the table, right? It's like, it's about 60% reduction in CPU. The most solid blue is like, if you don't recompile it, this is what you get, right? But the lighter blue portion is really, if you wanted to use the Arch option that fits the platform, this is how much more you get, right? So this is so basically, even if you have run the, if you recompile the 6.4 program that you compile the 6.4, you can still get a 5% CPU reduction, in that. And I have to mention that our benchmark suite is more geared towards the compute intensive side, right? So that's what we're gonna, get with 6.5. And and overall, like if you look at over time, the hardware and software, performance, you actually see a more dramatic reduction, right? If you look at the solid blue line, that's really, if you don't do anything, you use a 4.2 code that you compile in EC12 and you keep running it, the hardware will still give you pretty good, acceleration. But if you combine it with the software, with the compiler, then you get much more, right? So that's why we do recommend that, you stay current. And for the, for the performance intensive part of your program, that's always a performance bottleneck. We would recommend that you either recompile it or optimize it with ABL. So besides the hardware exploitation, we also have a lot of new language features that we ship with every release of the compiler, right? We started with 5.1 and 5.2. That's really the biggest change, because we did change the entire optimization infrastructure there. And then, and then the new runtime and everything. That's why, if your COBOL program has bad practices in it, it gets exposed here because of the infrastructure changes. And because we use hardware, so we have to be more precise in terms of what we feed the hardware. So things like JSON, UTF-8, and those Java interoperability 3164-bit interoperability. That's all being introduced, you know, in the software side, in the language side. So basically, all these things are also designed to help customers modernize their COBOL applications. So with 6.5, you know, obviously, you know, we're actually from 6.4 on, we're actually trying to introduce some more modern support, right, for language support for new developers, like user-defined functions. Now we're going to be bringing in user-defined types, which is it really you know, it's very familiar, you know, feature that is in other languages like C. It's called type def. We're bringing it to you know, to COBOL. And obviously, and another thing that we brought is vSAMDB support. Right? Traditionally, COBOL is very good in processing structured data, like from databases and, you know, from vSAM and all that. But you know, now we can actually also handle some unstructured data stored in vSAMDB, which is also called No Easy SQL. So this product on Z has been around for a while, and it has the APIs, you know, to work with Python, Java, C, and assembler. But now COBOL is part of that as well. So you can actually, you know, share the data, you know, vSAMDB, and you can actually use the same, you know, process the data that is stored in there. And the data is stored as a JSON file. So it's kind of like the unstructured is like a typical NoSQL database that we're actually is supporting. And I'm going to leave it there. So the exciting thing here is like everything has been, you know, centered around the compiler, and that's really all we got for a long time, right? But we also then we came up with the binary optimizer because not everybody can, you know, have the time to move it right to compile the entire code base. So we also found out that a lot of the code base is not being compiled. So you know, we brought out the automatic binary optimizer. You know, to help customers get the performance improvement, but without recompiling. And Watson Code Assistant for Z, I think Benoit did a very good job in talking about it. It's really the one-stop shop for all the, you know, all the modernization needs for COBOL, PL1, and all these you know, critical applications on Z. We contributed to a capability called code optimization, and I'm going to talk a little bit about that afterwards. And obviously, you know, when you modernize your code, you can actually use different languages now because we're talking about interoperability like Java. We're also working on Python and COBOL interoperability and stuff like that. You can argue that, you know, why don't you use APIs? But, you know, the question, the answer is like, if you're the same application, APIs doesn't really make sense because it's just increased overheads, right? So the interlanguage call aspect is still very important there. And recently, we have put out something called the COBOL Upgrade Advisor. The reason is because you know, a lot of customers are still stuck in the COBOL 4.2, and we try to we wanted to help them accelerate that you know, that upgrade process. So you know, we just recently worked with a customer called CICS, and they are struggling, you know, to upgrade to version 6, and they actually did it all manually. It took them 3 years, 40,000 you know, COBOL applications. But then they see a lot of benefits from it, right? One is like that obviously they can optimize the applications now. They can see you know, a CPU reduction. They have cleaner code, and all these years, like, you know, they have been, you know, paying for you know, extended support for the old compilers because they are a bank, then regulated business. They cannot be using unsupported you know, software. So now they can save all that money, and you know, because they involve their staff, you know, their programming staff to clean up the code. Now the programming staff knows more about the you know, the application, have more understanding of the application, and they actually have been able to reduce the technical debt in there. So this is really the benefit of really you know, going through the upgrade process. But you know, but not everybody has you know, will be able to do it manually, and not everybody can spend 3 years, you know, up for a large part of their you know, their development team to do this kind of work. So that's why we came up with something called the Upgrade Advisor. And it basically uses a VS Code interface, and it has a backend engine part that actually monitor the application so it tells exactly what you have on the platform. Because one of the challenges for COBOL application is like, I'm running a lot of COBOL application, but what is actually running on a platform, right? So this tool can actually help you do that, and it help you also, with the compile options that you need to turn on, and basically tell you when your object is being, it was compiled and what options and things like that. So you can actually get a lot of insight into the application before you start to even upgrade, right? Do the upgrade process. And the next phase is like we're going to be working on some automating some of those processes, make it even more easier. So I just wanted to leave you with ABO is that it is complementary to COBOL, because the thing is that we wanted you to use the COBOL compiler to be the production compiler, and the part of code that you use, which is probably the bigger part of code that you actually compile all the time, you can actually take advantage of ABO. And the performance there is similar, right? It's about, it's about 1 or 2% difference. When we first came out with ABO, it's about 10% difference. But now we actually, because it leverages the same optimization technology, we're able to shrink the overhead to around, to pretty similar performance. So WCA4Z, Benoit did everything. I just wanted to talk a little bit about the code optimization advice and what it's for. The reason it really provides good performance inside of your code, like what Ben was showing in the demo, and it identifies performance issue at the source, and it provides any prioritized and actionable recommendations. So you can actually see the performance, improving performance in 2 stages, right? One stage is like you use the optimization technology to work on the code that you already written, right? So ABO is already compiled, so basically work on an object. The COBOL is really something that you have, newly written code with code that is written many, many years ago, and you can mash it in together, and then you compile the code, and you optimize it that way. But for this product, we basically give you the insight view, which basically we actually give you the source recommendation that you basically see that, hey, we monitoring running the source, we actually see some inefficiency in your code. Maybe you're using the wrong data type here for the loop, for a loop counter, which basically that is very inefficient. Maybe you can change that. So you can actually see that if you clean up the code that way, you can actually let the optimizer do a better job for you, right? So as a result, you get a better performance out of for your application. So obviously, looking at performance, it requires a lot of skills like COBOL skills, application skills, even performance analysis skills. But for this, basically, we give you all the information. So we really reduce the skill the skill gap, and give you so that you can do a quick resolution to any performance issues. If you have performance issues that you found in production, that's a lot of pressure. So that this tool can actually help you do that. But most importantly, we would like to put performance as part of the pipeline, so you can actually shift left. So hopefully, if you do this thing, if your developers actually are looking at this thing and cleaning up the code as they go along, for the programs that they touch, then you'd be able to really prevent a performance problem before it even happen, right? Because you actually be proactively looking at it and cleaning it up. So that's really what we're wanted to be. Hopefully we can bring the biggest value out there. And basically it is again a VS Code interface with an engine running on the in the COS system, and it really monitors the run. It has a profiler. It profiles everything. It collects all the information, and then it feeds it to the analyzer, and then it generates the report. The report is in the form of JSON that can be rendered back into the UI. Then with the UI, with the Open Editor, you'll be able to very easily manage, navigate that changes. Yeah, I think I'm going to stop here because I think I'm 5 minutes over. So
yeah, but
so I'm going to turn it
very
back
interesting.
to Stuart. There's a lot of information, but very little time. So
yeah, Marcus, you asked a question about, you noticed there's 85 new high-level assembler instructions delivered with the Z17. Most of them to do with AI vectors. Can someone comment on that? Who were you directing that at, Marcus? Okay, if Marcus can't answer. Oh, you're here. Who was it?
Anyone who can comment, really, probably Roland, but anybody who's got information about the new vector instructions on the Z17.
I can get that answer for you, but I don't have the answer with me right now, so I'll get back to you on that one.
Thank you, Roland. And we know you've got a pressing engagement to go to, so if there are any other questions, we'll loop back, so you don't have to stay with us for the rest of the session. Thank you very much for that content note. Always very informative. Right, so we've analyzed, we've refactored, but ultimately you've written a program, you've got to run it somewhere. Obviously, best place to run it in the world is not batch, it's not IMSTM. It's got to be CICS, right, Ben? It's got to be the best place to run a program, hasn't it?
I think you're right. Yeah, I absolutely agree with you on that one. So hopefully
and you're going to talk to us now about simplification around the configuration, eh?
Yes.
If it wasn't already simple enough, so take it away. Thank you.
Right, yeah. So thanks, everyone. Thanks for having me. I think hopefully this will be relevant even if you aren't kind of on CICS yet, you don't interact with it, because hopefully some of the concepts maybe it will get you thinking about anyway. So don't hang up until you've given me a go. Just a bit of a hello. I am a design principal on CICS, and that means that I'm responsible for the user experience of this big beast, which is 55 years old, and sort of trying to drag that into the modern world of user experience, which is an interesting challenge. And one of the challenges we've been looking at recently is around configuration. So I'm going to get that off the screen and move on to some JCL. This is what we're here for, right? This is what we're here for. A bit of JCL. We've already had it mentioned in the comments a couple of times. Is this fine? Well, I'm sure perhaps there are some people on the call who are like, I know exactly what's going on here. And then there might be others on the call who aren't. They might be newer to the system. And there's actually quite a lot of stuff going on here that is quite confrontational, I think, to start with. But actually, is it really all needed? So for starters, there's things here which basically relate to it being kind of, it's punch card heritage, right? Okay, so we can get rid of those things. And all right, it's already starting to look a bit easier already. But then there's also things that, well, this is CICS, this is running CICS. I can see DFH SIP at the top. Also, there's a whole bunch of things which have disposition shared. It's got to be that way or CICS isn't going to work. Let's get rid of those as well. Okay. Then there's some hidden content that only becomes apparent at runtime. Well, maybe we could expand that, but for the purpose of this, I'm just going to kind of get rid of that, because where it's hidden, I can't actually work out what's going on before I actually run it. I'm only going to find out once I run CICS as to what the config is supposed to look like. And then there are variables that only become apparent at runtime as well. So let's get rid of some of those that are going to be kind of resolved and resolve them out right now. Then there are other variables in there, and those are specifically for rollout of maintenance. They're just in there kind of just in case for that very short period where you're rolling out maintenance. Let's get rid of those because they're also kind of complicating matters. And then there's further bits in there, data sets that are only included, they're empty most of the time, and only in the case of emergency would you put something in there and restart the region, and lo and behold, you'd have this kind of emergency library put in there. So let's get rid of those panic libraries as well, and remove those, because I can't really tell that configuration about, it's got a ++ APAR in there or something. I can't really tell that from this configuration. It's not being very useful to me. And then there's also this duplication of keywords, things that are really kind of just going over and over and over. Let's get rid of them and just try and kind of strip it back to what what the actual intent is behind this JCL. So already we're starting to see something that's kind of a lot more apparent, perhaps, as to what's going on. That there is a program that's running. It has a bunch of different data sets of different types that may be used for input or output, and some parameters. But I mean, I didn't even talk about things like the other configuration files we have in CICS. There are things like feature toggles and resources that you have in the CSD, and files are used by particular resources like JVM profiles and pipeline conf. Anyway, I haven't got time. Then there's things like different formats. So over the course of the last 55 years, different formats have come and gone and been, de rigueur, and they have different benefits and so on. But actually, you've got to learn each one of those. There's some opaque acronyms that are still in that JCL. Things that have to be short because you kind of want them to be readable in a line of JCL, or they've got to be less than 8 characters or 12 characters or 16 characters. And ultimately, I still don't know what's going to happen when I run it. So imagine that I'm a new system programmer coming to this and I'm being confronted with this. Maybe this is the kind of reaction that one might be having on your first days, weeks, and so on as you return home. So what we're thinking about is, what if this wasn't the case, okay? What if you weren't writing JCL? What if the config was in one place, or at least in fewer files that were kind of brought together? What if it was all in the same format, so you weren't essentially speaking different languages from file to file? What if you got in-editor help for what you're allowed to write, what's not spelt right, what's not allowed here, what's incompatible with that other setting? Or what if you could reason about what will happen before you run it, and you could easily manage the whole thing as configuration as code, and then get the benefits that you get from that about having kind of you've got it in source code management. You can see who did what, when, why, and how to roll it back easily. So that's the kind of the problems we've been thinking about and what we'd like to get to. So enter the hero of our story, CICS config. So this is a utility we've been working on recently. The rough gist is that you keep your config as code, probably in source code management somewhere, and it's kind of unified, same format and so on. You can run that through a CICS config tool, which turns it into the things that we kind of, when we're more experienced, we expect on the mainframe, that config that's laid out on ZOS. So on the left-hand side, you've got the kind of the simplified version that's only talking about what it needs to. And on the right-hand side, it should basically look the same as it always has done. And ultimately, the conclusion will be the same, but you have much better qualities of being able to develop it in between times. So let's just have a quick look at an example of that running. I'm in VS Code here. I'm just I've got a file open, which is a config file. It's in YAML just as a format, which has got kind of enough to it to help us with things like lists and dictionaries, keys and values, and so on. But ultimately, let's not turn that into a religious argument. But it's kind of starting to strip down some of the options you can do and the ways you say it, and it's giving a bit of a hierarchy and things like that, so that you can understand a bit better about what it's doing. And then, given you've got that, you can start up the terminal on ZOS, run the tool on this file. It's going to run over that. It's going to go, right, this CICS region, we need all these data sets that are going to back that. We need some startup JCL for that. I'm going to infer everything I needed from it, from this single config file. And ultimately, that's generated the JCL for me. It's generated all the other data sets for that region. And it's using kind of all the most sensible defaults and things without me having to think about that. I could put them in if I wanted to. I could change those around, but much faster. Much easier to kind of reason about and go, this is a sensible thing to be talking about. So I talked about this, and that's what we want to see. Well, actually, it's more like what we'd like to do is see something that looks like this. because as we've talked to customers, it's become clear that like this is exciting, but I'm over here and there's a big chasm between here and there, and that is I don't have like a money to pour into a project to do this conversion or whatever. How can I get from here to there? So what we're really thinking about too is how can we discover what's already there and turn that into the config as code, ready for you to check into your source code management and to manage easily in the future, as we previously went through. So yeah, looking at that discovery aspect too. Some of the principles that we've been thinking about are these. So for starters, there's consolidation. It's coming down to like a single file or certainly fewer files. And they're all one file format as well, so that they're easy to think about because you're not learning a new language per file. Elimination is another aspect. So getting rid of things that we don't think people need, at least for now, like until they're asked for. So if you went through like the JCL reference, you could see all these different attributes, but we don't actually need all of them because they don't make sense for kicks or whatever. So we can get rid of those. There's explanation. So there's the idea that you can be being told what you can do at different areas in that file. So here it's telling me what I can do inside this kicks datasets area, and as part of that, it's even giving me some help about what it is. That's one area of explanation. The other part is we can actually make the terminology like longer. It doesn't have to be 8 characters or 4 characters or 12 characters or whatever. It can be longer. We can talk about it in terms that make more sense to people when they read it. And then that conversion to the 8-character thing can happen later. So it actually makes sense when you look at it. And then there's communication. So can the system programmer communicate their intent through this configuration? Let's say you've got something like this. Okay, this is kind of like a very quick conversion from something that already existed to this way of configuring. You probably wouldn't realize, apart from the fact that it says at the top, unless you're familiar with debug tool, that this is a region that's got debug tool applied to it. That is a bit of a giveaway at the top. I must change that for next time. But basically, there's a few parts of this, like there's an extra DD in there that pulls in debug tool. There's an area in the group list as to what's going to be installed. There's a particular parameter that says turn debug tool on with yes. What we're doing is saying, given those things are all related and those will be dotted all over your JCL, if you went and looked at that, let's let the system programmer communicate that by saying, yes, I want debug tool on. And there's one bit of required information, which is kind of like the high level qualifier for where the debug tool datasets are. And that's all you need. So now we've got 1 or 2 lines in the config that actually communicate what the system programmer meant. And then finally, there's also the guiding principle of extension. So whether that's IBMers coming along and bringing their the kind of extensions to that, whether it's customers who are saying, we do one thing a lot, maybe we could make something that kind of expresses that very easily. Or whether it's tool vendors who are coming along, a bit like debug tool there, coming along and extending it in some way that makes the configuration work for them. And who knows, in the future, it may also extend not just to kicks, but to other middleware as well. So that's it, really. I hope that's been kind of an interesting foray into what we're thinking about at the moment. So I would say, go get kicks config from the KicksTS Open Beta site if you can, and try it out. It's just a Python tool that runs on ZOS. So you can kind of see, can you reproduce kind of before and after I had this JCL, can I remake it through simpler config? And have a think about how would you simplify config for KicksTS or indeed anything else on Z. So get in touch with LinkedIn or in the comments or whatever, because I'd very much like to hear about that. So success is inevitable. Thank you very much for listening, and back to Stuart, I suppose.
Thank you so much, Ben. That was really interesting what direction potentially things are going. And as it's recording now, obviously that you're committed to that direction of travel because we've all seen it.
Yeah,
so
I've been vegan.
Cool. No, it's really good because you can just see that the next generation of people, custodians of any huge retail organization or bank or airline are going to find some of this stuff a little bit easier to understand than picking up JCL and looking at it and thinking, I have no idea why that's in there. So that's fantastic. Really, really like when we're thinking about our obligation for succession management. So brilliant stuff. Okay, so we've rattled on. We're nearly at the end. Some of you are sighing relief. We do like to hear your feedback, good, bad, indifferent, whatever. So there's a SurveyMonkey survey. I popped it in the chat. So before you lose access to the chat, if you wouldn't mind contributing in some way to us. Anything you want to add on that bit, Matt? No, got a shake of the head. So we're always open to ideas. You've perhaps seen us on LinkedIn or wherever you've seen it. That would be great. If you don't want to do SurveyMonkey or you can't do it because of browser restrictions, then we're always on LinkedIn. We're looking for ideas for the next event, which will probably be in 3 to 4 months or something, you know, so it'll be after the summer break and before Christmas. We'll be doing something around 90 minutes again. So if you've got some ideas, we can probably find, you don't have to suggest the speakers, we can probably find the people that can do content. Please connect with our speakers on LinkedIn or whatever if you've got other questions. And I don't know, Matt, anything else you want to talk about?
Am I on mute? No, just if anyone's got any other questions, we've got a few minutes to take any more questions if anyone would like to unmute.
Thanks, Marcus. Yeah, well done, Peelings. Fantastic. Well, we're on time. How about that, Matt?
Brilliant. Great job,
Thanks
Stuart.
to all us great speakers. Really enjoyed the session. Even though we put it together, it's always good to be entertained and be educated. So from us to you, thank you. Speak soon.
Thank you very much.
Thanks, everyone. Brilliant. Great job, everyone.